Hey, how's everyone
Hey
doing?
everybody, thanks for joining us here today. Sorry for the brief little glitch on our side. My name's Chris Munns. I am a senior developer advocate for serverless here at AWS here from New York City. We've got an awesome session here planned today. I'm joined by Akersh from the Alexa team who is dialed in from Seattle. So we're here coming in from two different sides of the country. Sorry if that causes any brief delays. We're going to try to work with it. Kirsch, why don't you
Yeah,
say hi and introduce yourself?
sure. Hey, everyone. I think Chris did a great job. What's really cool about this is that I can say good morning and Chris can say good afternoon. You don't get a lot of streams where you can do both together, so that's pretty good. Cool. It's like an East Coast, West Coast thing, right? I mean, this takes me back to the 90s. But yeah, as Chris said, I'm a senior solutions architect on the Alexa team. And what today is kind of really about are two challenges that we've got that are open. One is around Alexa. The other one's a little bit about serverless repos. I'll let Chris kind of talk about serverless one. But we've got the Alexa Skills Challenge, Tech for Good. If you look in the description on the stream and you go to Alexa techforgood.devpost.com, Chris is pulling it up right now. You can see what it takes to kind of participate and register for this hackathon. There's tons of prizes we're giving away, up to about $120,000 in awards. And there's more than just one grand prize winner. In addition to that, we're going to be donating about 20 grand to one of 11 nonprofits that the hackathon is kind of supporting. So that's really kind of the idea. Back to you, Chris.
Awesome, thanks. So as Chris put it, there's kind of two hackathons that we're covering in one Twitch session today. So there's the Alexa Skills Challenge Tech for Good. There's also the Serverless Apps for Social Good hackathon that we're also participating in, and you can find that at serverlessrepo.devpost.com. We're also giving away a number of prizes, over $22,000 in prizes, I believe, in terms of donations to charities and for winning projects here. And again, you can check that out at serverlessrepo.devpost.com. So what we're going to kind of do today is walk through an example of a project that you could potentially build yourself in order to kind of cover the two of these hackathons from both angles. So we're going to build an Alexa skill, and I'll leave it to Akersh to lead us for that one. We're also going to be putting something or accessing stuff that is in the AWS Serverless Application Repository, and I'm going to be taking on the backend side for that. Now, when we were thinking about the hackathon and trying to think about what we wanted to build and what would be kind of an interesting idea, for me here in New York City, I love the New York City parks. There are parks all over the 5 boroughs. There's always things going on in them, and sometimes if you take a walk through a park on a weekend or at night, you'll see all sorts of events, and you're like, wow, I really wish I knew what was going on here. And so the parks folks have an awesome website that you can go to. It's New York City govparks.org/events, and it provides all sorts of information. So you can see things that are coming up. We can see the categories they're listed by. We can see where they're located, the start time, the end time, a description about them. Now, I've got 2 little kids, and so for me, events that are good for my 2 little sons would be a lot of fun. And so I can filter for best for kids, and then see the events that are listed here about the kids. I could also do things like filter by neighborhood. So I happen to live in Manhattan, and so I could come down here to the borough and filter at least by the overall borough. So I could say all Manhattan neighborhoods, search by that, and it's going to come back with all of the parks that are in Manhattan. We see things here for Central Park. There's stuff here for Randall's Island Park, not technically in Manhattan, but I guess they consider it that way. Stuff by the Hudson Park. So there's all sorts of cool stuff here. Tons of events. Literally, like, we're filtering right now here, and this is from September 7th to December 30th, and there's 83 events that are best for kids in my local park. And so,
when Chris, I'm kind of gonna give some deeper insight in the backstory. Like when Chris came to me and described that idea and that he really loves the New York City Parks events calendar for kind of finding things to do, and showed me this website, I was like, yeah, this is this is amazing. This would be a wonderful use case for a few different things, right? I guess one is when you're really working with the GUI, you've got all of these options presented to you all at once. So there's a ton of information, and you can kind of click around and you can select what you want. Like Chris, you just picked best for kids, right? I would pick, I don't know, I'd pick like nature and history because I like to be outdoors, and then you reminisce on the days of yore, I guess. But yeah, we got both those things going on, and that's what GUIs are really, really good for. Now, what's unique about using Alexa or what we call voice user interface is they're really great at distilling information into just a pure essence, right? So maybe you want a suggestion on a park, right? But at the same time, you don't want to really pull out your phone. Chris, you said you love to do this with your kids, so you have them in the room and you kind of have a conversation with your kids and Alexa to figure out if there's something cool going on, right? It's amazing. Like for me at least, I could be, washing my dishes and saying, Alexa, hey, is there anything to do outside? Ask New York City Parks for something going on outside this weekend, right? And I said that this is an excellent use case for it, but we'll talk a little bit about how we kind of keep those design considerations in mind. But at the same time, this is amazing for good. When we talk about creating a lot of social value, one of the big things too is getting people outside, engaging with their community, really supporting it in a way that makes them participants. So this is an all-around great use case, I think, for both this challenge and for learning a little bit about what it takes to kind of build an Alexa skill on top of that.
Absolutely. So, part of the idea here was, this website is awesome, but my kids are kind of little, and there's times when I need to kind of think on the go and move quickly. And so how can we take the data that's here and in this awesome kind of really data-dense web page and make it available for me to ask Alexa about, questions about the park? And so there's kind of two aspects to this. One is we've got to get the data out of this site. We've got to get it out of this site and make it accessible in some means that we can make it available to Alexa. And then the second part is obviously having an Alexa skill that can then interface back with this data based on, aspects of what I'm looking to do and where I'm maybe looking to go. And so we're going to kind of walk through those two aspects of how to do this.
Yeah, and that's really reticent to just general web architecture, right? I think what Chris is saying is like, how do you get the data from a source and make it digestible computationally or programmatically, right? So you got your back end, and then you have your front end, right? How do you create a layer that you can interface with? So I guess that's what we'll do, right? Let's, kind of work on the back end first, and then we'll put together a front end, and then we'll plug them in together.
And so, like all great cooking shows, we've cheated a little in that we have one empty oven, and then we've got one oven that's got a fully baked cake in it. Now, we're going to talk about a couple of different technologies that we're going to use to effectively make the cake today, and the cake, in this case, being the thing that's going to get the information out of this website. The New York City Parks website, in this case, does not have an API for us, so there is nothing that we can directly plug into. And so essentially what we're going to need to do is take the data off of this page and put it into a database for our skill. And so there's a number of different ways that we can do that, but I think one of the easiest ways is to build some sort of web page crawler or scraper, if you will, that will take the data off of this. And so what I'm going to need is some sort of compute service in order for me to run my code and some place to then store that data. And so, again, I am the lead developer advocate for serverless here at AWS. So we're going to leverage some serverless technologies for this. The primary one that we're going to leverage from the compute standpoint is a service called AWS Lambda. Now, Lambda is a serverless compute service. So basically the way that it works is you write your code, your business logic, you bundle into an application artifact, you send that up to Lambda, you configure an event source, maybe configure some databases or something that you want to store data in, And when your Lambda function is triggered by that event source, it will cause that code to be fired up on a server somewhere, but not one that you manage anywhere, and do exactly what it is that you need to do, or that your code has been configured to do, I should say. And so in this case, you don't manage any servers. Basically, the infrastructure comes and goes on the fly. You pay in the hundreds of milliseconds, and there's actually a pretty significant free tier, so it could cost you nothing to run through this. And so we could build that Lambda application and put our code into it and execute it. And so what I've already done is gone ahead and let me make sure I've got the right one. Yep. And we've got a repository out there actually that has the finished function in it. But what I want to do is actually walk through what's going on inside of it first. And so if I go into my Python script for this code, and actually let me hop over to an IDE real quick here. So I happen to have an IDE up and running in another AWS service called AWS Cloud9. Cloud9 is a managed IDE that is completely hosted for you. And so you can actually create these really kind of awesome, at least this is what I do, like ephemeral dev environments that I could fire up, connect to in a browser, install the tools that I need to, although it comes with a lot of tools already, edit my code, configure things, launch stuff, and then at the end of the day, just kind of walk away from it. And so this IDE environment here, I've connected to it right now from my work laptop. The other day I was connected to it from my home workstation, and everything basically can just stay inside of that environment. So again, what I mentioned before here is that this application is going to run inside of Lambda. Now there's a couple aspects to how Lambda executes and runs code. One of the most important ones, and I'm going to zoom all the way through this code here, is the concept of a handler. And so in a Lambda function, the handler essentially is the injection point for where the service is going to interface with your code. And so this is my Lambda handler. It's basically just pretty straightforward to find. I pass in an event, I pass in some context, and then from there, it will execute what I need it to do. Now, if we go back to this New York City Parks events page, and let's say that I wanted to see all the events between today and let's just shrink it down just to tomorrow. All right, so I'll make it the 8th. And I cared about all of the nature events that were in Manhattan. And I search for this. So if I search for this on this page, I'll see, again, a whole bunch of information. I see information, in this case, let's go to one that's not canceled. So I'll see the title of the event, where it's located, start time, end time, a description, some categories. I've got the date over here and the day of the week. If I scroll down, I'll see obviously a whole bunch more events down here. And then there's actually multiple pages of events. So I can click over onto the second page and go in and see all of the events that's listed here. So what I know from the data on the New York City Parks website is that I have multiple pages of content. Each event has, again, a grouping of records and data points that I want to find a way to read and capture. And so I'm going to need to think about how I could parse and iterate through each of the events on all the pages that I have to gather all of the data that is necessary. Now, real quick, if I go ahead and look at the page source for this, and the Parks page has this wonderful little header of their logo here with a leaf.
Is that a maple leaf?
I don't know if it's a maple leaf or I don't know. It's a green leaf. It's a good question. Maybe somebody here in Twitch knows what kind of leaf the New York City Parks Department uses here in their logo. But we're going to scroll past the leaf, and what I have here is, oh boy, a whole bunch of HTML, and it's really deep and dense with information, and so finding stuff in here is a little challenging. If I come back to an event here, right? So the Bronx Kill Salt Marsh Tour. I can come into my source, and I could find that event. But again, what I've got here is kind of a messy structure. There's all sorts of HTML. There's all sorts of various HTML tags as part of this. But one thing that I found was really interesting when looking through this is they reference a item type here from schema.org. So schema.org is actually a pretty cool website. And what schema.org does is it's kind of an open, collaborative way of specifying standards for all sorts of different data schemas. And so they actually have one here for an event. And we can go and look at this schema and what's inside of it and various things about it. And so what's pretty great is that the New York City Park Service actually does follow the schema.org schema for event. And I actually found this one crawling through the HTML trying to get some aspect about what's going in here. So what's great is that I know that there is some sort of structure that's being followed. And so the question becomes, well, how can I take some amount of code and crawl through this HTML document in a structured way such that I could pull out certain records that are pertinent to me and, again, make that data available. So there's a couple things that you can do. There's a couple different ways that you can do it. I like to lean on the shoulders of open source where possible. And so there's this really awesome open source package called Beautiful Soup. And so Beautiful Soup, again, you could find out there just by searching for Beautiful Soup. It's the first thing that comes up. And so what Beautiful Soup will allow me to do is actually take an HTML document that I've downloaded, essentially pull down a web page, and then allow me to treat the individual HTML tags as an object structure that I can parse through. And so this is a really great tool if you need to do any sort of like crawling or digging through or spelunking through HTML documents and pull in various bits of data from it. And so what I've done here in my code for this is I use Beautiful Soup to pull down my data. Now I'm actually going to, real quick here, let's see, we're at 1247. Let's actually just kind of come up with a test document here. And what I'm going to basically do is walk my way up through where I ended up here at the end. So I've got a bunch of things that I'm going to include. I'm just going to bring over all of my imports. So in here, I'm going to bring in my imports. Let me just save this real quick inside of this. And we'll go through how each of these imports here helps us here in a second. I'm also going to bring in some bits from my handler. And we'll go through all of this here in a second. Okay, so just starting out, what I'm going to do is I'm actually going to comment out a bunch of things. So let's actually just comment out all of this. So again, going through this, what I'm going to need to do is I'm going to need to iterate through all of the pages that I have. And then from each of the pages, iterate through all of the events that are there. And then from each event, pull out the appropriate details that I need. So first things first, let's actually figure out how many pages of content that I have that I'm going to need to iterate through. And so the way that I can do this here with Beautiful Soup, as well as the Python request package, is what I'm going to do here is I know that I have a certain page that I want to crawl. I'm also going to pull in some headers. Actually, it's pulling up a bunch of things here. By the way, we've got the Chime chat up. Feel free to throw questions in here that you might have for us, and we will definitely try to get in front of those here. All right, so real quick here, what have I done? So I just again pulled in some stuff from my existing Lambda file here. I've got a bunch of packages that I'm importing, and we'll cover those as we get through things. I'm going to set up the headers for my requests. So being, or at least trying to be a good web citizen, I do want the people on the park site, if they look at all at their HTML logs, to wonder who it is that's hitting this site of theirs and pulling out the data. So I just have a very basic user agent here. The other thing that I'm going to do is I only want to crawl for a certain amount of time. Currently, the park site has event information through the end of this year. And so we've got a good couple months ahead of us. There's a lot of events there. There's actually into the thousands of events from what I've seen before. And so what I'm going to do is I'm actually going to crawl just a certain number of days. And so I'm actually going to pull that in from a environment variable inside of my Lambda function. So let me just pull that in here. And what I'm actually going to do is set a default here for 1. And so what this code basically does is it says, hey, if you have an OS environment variable that has been set for this Lambda function, we're going to use that. If not, we're just going to go down here and default to 1. And then what I've done here is I find out what today's date is, and then I take today plus whatever the crawler day's value is. So I'm going to actually go here and say, okay, I want to find today plus 1 day, and that's a value that I care about. And then I have my base URL, which is the New York City govparks.org/events. And then what I'm going to tell it to do, and we can actually see this up here in the URL on this page, is that they have a pretty straightforward syntax. There's F for the from date, T for the to date, and then there's pages and filter categories and stuff like that. So what I have here in my code is that I have my page URL, which is again New York City govparks.org/events, from today to today plus. And that's something that I'm going to use to essentially put together the URL that I'm going to crawl. So the next thing I need to do is actually crawl something. So what I have here is a very basic function that basically called getPages. And what getPages is going to do is it's going to use the requests function to make a request to the URL that I've constructed, passing in the headers that I have, and it's going to pull down that content for me. Then I'm going to pass in that page content into Beautiful Soup using the built-in HTML parser that it has. And they have a couple of different parsers out there, but that's maybe a bit beyond what we want to cover today. And then right below this is where it starts to get interesting. What I can then do is actually find inside of that document, the HTML document, certain structured tags. So if I go back to this page here for the Parks page, and again, what I want to do is figure out first, how many pages do I need to crawl through? So I see here that I'm viewing 1 out of 10 events, or viewing 1 to 10 events out of 133 possible. If I come all the way down here to the bottom, I see that that's actually 14 pages of events. Now, the easiest thing for me to do here would be to say, okay, I know that there's 10 events per page, and currently there's 133 events. And so you could do the basic math of figuring out that that roughly works out to be 14 pages, or exactly 14 pages in this case. And so what I want to do is I want to take this blurb right here, again, this viewing 1 out of 10 blurb, and I want to use this to figure out how I can get back this number here of 133 events. And so if I go and view the source for this one again, a second here, and I find the string viewing, what I could find is that this is in a paragraph tag with the class set to alert. And so here in my code, what I do here is I'm going to crawl through my content, and I'm going to find the P tag, paragraph tag, that has a class set to alert. And then I'm going to come back and get that text. Now, I'm going to take it one step further here, because if I go back and look at this, what it's going to come back and give me is this full string here. It's going to say that I'm looking at 1 of 10 out of 133 events. But I really just care about the 133. And so I have a very basic kind of regex here that is going to come and pull out this information. And so let's actually real quick see here if I can execute this. Oops. And make this work. Now, one thing that I'm going to, let's actually just return total events. I'm just going to cheat here real quick. Okay, so I have a Lambda function. It's super basic, right? It's got some imported values. It's looking for an environment variable. It's got some constants that are being sent here, some variables for other things. I have one subfunction called getPages, which crawls a URL, pulls in the data, looks for certain tags, and then gives me back basically a total number of events that are listed here. And then down in my handler, I basically get this value. Again, we're kind of cut ahead of ourselves here from this function. So let's actually go and execute this. One thing I have to do, though, before I can execute this is I need to actually configure the function inside of the service. Like I need a way for this function to be executed. So here at with Lambda, we have something called Serverless Application Models. And so with Serverless Application Models, what I can do is define my function such that when I want to deploy my function, I can use this template file to configure my Lambda function on the main service. And so I'm actually going to use this, though, to do local testing of my Lambda function here inside of the Cloud9 IDE. Now, this is already configured for the main function that's out there and loaded, but let me just go ahead here and create a second one just to give you kind of an example of how this works. So I have my tester function. It's got the handler living there. Let me just erase this real quick here. And what I should be able to do, if I haven't messed up anything from my coding, is I should be able to come over here on the side to this AWS resources page, refresh this, go down to tester, click run, and run local. And then pass in nothing, and let's see what happens. Awesome. So essentially what I've done here is I have a really basic kind of shell of a Lambda function, right? Pretty straightforward. It's just going to go and get the total number of events that are here. I've, in my SAM template, defined this tester function as something that I can execute. And then inside of the Cloud9 IDE, using the SAM interface and SAM CLI's local testing capability, I've gone and been able to pull out that there are 342 events given the search that I'm doing here. If we actually go and we can check ourselves to make sure that this is the right thing. And so if I pump in the URL here, I see that if I'm looking from here, it says today until September 14th, that I've got 342 events. So in this case, it is all good. Now, why do I have 7 days worth of events instead of 1? Well, even though inside of my code, I set the variable here to be 1 days, inside of my template, I actually had it already defined as 7. So let me just go back, make this 1, again, just to keep the data clear here. Run this again. I've crawled 1 day and 133 events for this 1 day. Make sure this is showing up for everybody. Cool. Awesome. All right, so I've got the total number of events. Let's figure out the number of pages that I need to crawl. And so again, the number of pages that I need to crawl is a factor of the total number of events that I have, basically more or less divided by 10. Now, it's not just divided by 10, but it's rounded up to the nearest 10 and then divided by it. Because if I go to my last page inside of this, page 35 here, I may not have 10 events. In fact, I've only got 2 events. And so I need to account for that in my code. And so what I've got is a really basic kind of roundup function that's going to take a value, and it's going to, like the name says, end up rounding it up to the nearest 10 for me. In this case, it's also going to help me figure out the total number of pages by 10 events per page. Oops. Right here. Total pages. And then when I come down here, total pages is set. And let me just actually just do print total pages. Actually, let me make this a little bit prettier. Nope, cool. All right, so what I've done is added my roundup here. This is going to give me the total number of pages. Let's just print out total number of pages. Should be pretty straightforward. Uh-oh, I broke it. What'd I do? You cannot concatenate strings and integers. So we're just going to cast this to a string real quick here. And go ahead and do it. Great. So I find out here that now with this URL, I've got 1 day that I'm crawling. There's 133 events on it. Works out to 14 pages. Again, keeping myself true here. It's the exact same thing that we find out if I actually go to this URL, scroll down to the bottom, 14 pages. Okay, so that's step 1. Now I've got the total number of pages that I need to crawl. The next thing that I need to do is figure out all of the various events per page, basically all the events per page that I want to get through. And so again, in my existing function here, I'm just going to come back over and get all events. And let's go back here and add this function to my code. And then let's go down to my handler. And what we're actually going to do inside of this is we're going to, actually I already got this code in here. Let's come back into here. So what I want to say now is that per page, go through each page and get me all of the events that exist inside of a page. And I'm just going to do this in kind of a really basic kind of where loop here. Then we get to one other thing here. So when it comes to identifying the events on the page, there are some other things that I need to do. When I look at the page itself and I look at all of the contents for the page, let me go actually to the source code for this. Again, it's a little hard to find, but somewhere in here is the beginning of the structure for where the events are listed. And so this is actually inside of a div tag called events left column. And again, the way that I find this is, again, by basically parsing through the HTML manually and figuring out where this lives. So what I need to do is tell Beautiful Soup, hey, where can I find basically the content that I care about? And so I care about everything inside of the div tag for events left col. And so I have defined that inside of here as a constant. And so if we go down to the get events page, again, what I'm doing is I'm passing in a page counter, and then I'm making another request to a new URL. It's basically the page URL before plus the /p string, which the Parks site uses to define the page that I want to land on. And then I'm telling Beautiful Soup again to parse it, and I'm going to tell it to parse it looking for the div tag that is ID'd all events identifier, which is again this events left column tag. And then I'm going to pull that in. And so let's actually do that real quick here. And I'm going to take an event, and I'm just going to print out the first event that I find for this page. So this should be good. Let's go ahead here and test this again. Okay, cool. So, sorry, one second here, make this look a little bit clearer. Great. So basically what it's done again, it's called through the page, it's gone through each page, it's found the event structure, and it's returning back to me an event that it has found on this page. And so what I've got here is a whole bunch of HTML. Again, this is the same HTML that's on that page. It gives me all of the relevant information here about it. So I see in here things like cal month, cal day. There's things in here like the name of the event, the location of the event. So I'm getting a lot closer to what it is that I want to pull out. And so this is good. This is exciting. And again, I can go and confirm that this looks exactly like the schema does on schema.org. So I've got this, and this is a good start. Now let's actually go through and pull out the relevant information from each of these events. So let me come back in here, and I'm going to comment out this print statement. So now that I have my events, let's actually go and pull out the details from them. So again, I've got another function here that will allow me to pull these out. And let me just pull out some of the things that I have in my code here that are going to help make my life a little bit easier. And let's go back to my stored function here and pull out all of the events, all the event details. Sorry, what do I have so far? Sorry. Cool. So next bit of code that I'm bringing in here again from my pre-baked cake, as it were, is a function that is called parse events. So again, my previous function here called get all events gets all the events on a given page per page. And now what I want to do is actually go and pull this information out. Now, from the test output from before, we see that there are all sorts of other tags that have various bits of information in them. For example, we could see here a span tag that has the address, and again, it's stored as a schema.org postal address. We can see things about the start and end date, but unfortunately, one thing that isn't very consistent in how this is shown is that there's all sorts of various tags that are used. So I can't do something really easy like, say, For div tags, look for anything within this array of like the types of data that I'm looking for. Instead, what I kind of had to do was, for each of these pertinent pieces of information, specify the tag name, specify the identifier for it, and then get the text back from it. Now, again, Beautiful Soup is making this really, really easy for me. It's effectively allowing me to treat all this HTML as a parsable object. And so it's really pretty straightforward for me to go and pull all this out.
I guess something to note too here is that I guess one of the limitations would really be that the HTML has to be properly formatted, right?
Yeah.
If you ran into a website, for instance, that's got all sorts of div class tags and like random spam names, there would be no system that you can use to kind of isolate the data you need.
Yeah, absolutely. Beautiful Soup can do things, and there's a couple other tools out there that can parse actual tables. So it would have been a little easier if this was actually in a table format versus it just kind of being, divs and spans and everything else that is out there. But yeah, so you kind of have to step through this process as you're trying to figure it out. So I literally had to grab the pages, grab all the events on a page, figure out the structure, and then be able to go through it and pull that out. If I go back to my code here real quick, and actually I'm going to make this a little smaller so you can see it all. It's a little busy here, but let me kind of walk through logically what I'm doing. And so I pass in all the events from a single page here as this variable here, all events list. Now, again, all events list is effectively an array that I'm going to step through that has each item in the array is basically a dictionary of key values. So what I'm going to do inside of this is basically I'm saying all events in a counter. So again, there's basically 10 events per page. So I know I'm going to go 0 through 9 here because our counters start with 0. I'm going to look for the certain tag that has a certain attribute, and I'm going to pull out the information. So again, just looking here at this one that's called cal month, if I come back to my content that I've already pulled, I can see here that there is a span tag with a class equal to cal month. And then what I want to do is get the text that's inside of that. In this case, SCP for September. And so what I've gone ahead and already done is figured out where all of these things are labeled. So you can see here, some of them are spans. This one here is an H3, a header tag. Some of these things are in meta tags. So it's a little clunky to work through all of that.
Yeah, and I guess the other thing that I'm noticing here is like you kind of have the structure of like each entry in your database forming as well, right? Like it's going to be collecting location, a name, a start date, an end date, like a unique ID, which looks like is just a web page. You got borough, street address. That's cool.
Yeah. So again, I could pull out, again, looking back at what you would look at from a human perspective, I care about the address, the name of it, the date, the start time, the end time, categories and stuff like that I can use. So again, we're kind of doing the human parsing of all this information that is obviously stored somewhere in a Parks database, but we're going to make it available via our own interface here with Alexa. So I've got all this information. One thing about this that's kind of interesting is that sometimes the fields can be empty, and so that can be problematic. And so basically, if we come across where there is not a value set in data, we're just going to set it to null. And so we're actually going to set it purposely to a null here. And we'll talk about why that is important in a second. So I've got all this information. All of this should be set up. I've enabled it in my handler. Let's actually go ahead and test this. And real quick, what I've done is I have just kind of a poor man's debugging output statement here, which is going to take all of this information that I've stored and dump it out as a JSON object. Great. Okay, so we're crawling for one day. We have found 133 events on that one day. Works out to be 14 pages worth of events. And then what we can see here is the first event that we've been able to pull out of the page. So we see here a JSON structure that represents, again, everything that would be here as part of this. We've got the borough, we've got the categories, we've got description, the day, the ID of the event, which in this case is just like the unique URL for the event, as well as kind of, again, any of the other pertinent data. And if we scroll through this, we're going to see all of the data for all of the events that we have, all nicely structured. You can see here some street addresses set to null and some other bits about this. So we've successfully figured out how to pull all of the data off of the parks page. Now, what can we do in order to put that data someplace useful? So, want a database. Keeping with the theme of not wanting to manage any servers for what we're doing here today, ideally I'd like to find a database that I don't have to install any software for, that I don't have to do a lot of configuration for, that I don't have to think about scaling necessarily, or anything like that. And so here at Amazon Web Services, we have a really awesome database called Amazon DynamoDB. It is a non-relational key value data store that can automatically scale for you, does data replication, has all sorts of capabilities of a non-relational database. And so I have this awesome JSON structure, and let me take this data and basically toss it into DynamoDB. Now, this is pretty straightforward. So coming back in here into my test code, I am going to go ahead and re-enable and bring in a function from my main code here. Now, the function for writing this is actually really, really simple. Because my data is already in a JSON structure, I actually don't have to do a whole lot. All my items are essentially, all my items are predefined and structured. They've got both the key side and the value side. And so basically I just need to go and iterate through each of these JSON documents and pump them into DynamoDB. Now, much like with the counter for the number of pages that I have, I've also set up an environment variable for my database. And so I can take this in via configuration at real time, or I can actually go and have essentially a fail-safe in here. So let me go ahead and pull this in here. And so I have, in this case, a table called events table demo. And actually, just to keep me honest, let me go to the DynamoDB console and wipe out all of the data that is for that. Oh, actually, in this account, I don't yet have that table. So let me create that table real quick here. So events table -demo, the primary key I'm just going to call ID, so that's the ID of my event. Again, what DynamoDB does, it has all sorts of kind of cool stuff built into it. You can do things like have secondary indexes. You can provision capacity towards the number of reads and writes that you want, but you can also now set up auto-scaling for that. So it can scale based on how much of those read and write capacity units are consumed. I can do things like set up automatic backups, all sorts of cool stuff that I can do. But I'm just going to create this table. And again, I'm not setting up a server. I'm not setting up any networking. I'm not running a shell command to install anything. I'm not doing any of that stuff. I'm just going and creating a table inside of DynamoDB. All right, so that is created. Right now, it is an empty table. I'll zoom out a little bit here. If we come here to items and I refresh this, we've got no items. Well, let's go ahead and get some items into here. So if I come back to my tester, I have brought in my database table. I have brought in my database writing function. I have enabled it inside of my Lambda function handler. Let's go and test this and make this do its thing. So 1 second here, let me just bring this up. And let's execute. Okay, so unable to find. Yep. Okay. Cool. So again, I've got some good syntax highlighting in here. So it's going to default to events table -demo. Again, 1 day, 133 events. Let's go back to my DynamoDB table here, and go ahead and basically it's going to do a scan, which is going to give me back all of the data that is inside of here. And we see here that I've got a whole bunch of events that showed up. And if I go over to the second page of them, I've got 131 events. So what's a little interesting about this is that the code is running against a certain time zone. And so it's not going to give me, actually 1 second, let me see what it say here. So 133 events listed. I completed successfully. Sorry. All right, the mysteries of live demos. We found 133 events, but we only have 131. Unless the scan missed one or missed two coming back, we've lost 2 events. So you got me.
Maybe they didn't have IDs.
Plausible. It's plausible.
Yeah.
Although it should have coughed up an error for that. Oh,
Let's just pretend it says 133.
Everything is good. Yeah.
Everything is fine.
So, but let's go ahead and look at this, right? So, bird walk through Sherman Creek. If I click on this event and I look at the text for this, I see my JSON document, right? And so this JSON document is now represented here across the various attributes inside of my database. And so everything is good. We see here some null addresses where things aren't represented. We see start dates. We see the name of the location, the month, the actual location itself, yada, yada, yada. Basically, all of the records that I was looking to store are all in here, and things are good. Awesome. So this is here. I've got my Lambda function. It's all set up. I've been running this though locally, right? And so typically, I'm not going to want to run this locally from a test environment. What I really like to do is run this up in the cloud, as it were, and have it all executed for me. Now, this is where let's talk about another aspect to this, which is part of the hackathon that we have from the AWS side as part of the Serverless Application Repository. Now, I've got, again, here my code. I've got myself here my SAM template that I've been using to execute this code. And one of the things that I could do is I could say, hey, you know what? It'd be really awesome if I could take this application and I could share this application with everybody who's here. And so I could say, hey, Kirsch, if you want to run this code, here's a really easy way for it to be all bundled up for you to go and do that, and things would be great. And so again, yep, going back to our cooking show here, I have already done that. So yes, this code is available in GitHub, and you can go and find that here, but it's also available in the Serverless Application Repository. And so if I go and search for AWS Serverless Application Repository, I could come and find the main landing page for it. And then I could say browse all applications. And then let's go ahead and search for crawler. What is this? It just so happens that we happen to have inside of the Serverless Application Repository already the New York City Parks Events crawler. And so everyone that's watching the Twitch stream right now can actually go and find this and deploy this function. So this is live out there, and you can go and find it. And what you'll find is kind of a lot of information that we've been talking about here today. So in my README, I talk a little bit about what we've done, talk about how it works, talk about the number of days flag that you can configure, talk about the dependencies that we have. And so you can go and just click on deploy, and this will go and deploy it inside of your AWS account. So let me go ahead here and click deploy. Now I've already logged into my AWS console, and so all of this is here and figured out. I am going to give this a new name because I think I already have this one set up. Oops, how to do that here. Cool. So I'm just going to change this to be live, and I'm going to come down here and I'm going to say deploy. So again, what Serverless Application Repository allows you to do is bundle up a serverless application. So a Lambda function, a SAM template, any of the required dependencies that you need for that application to function. And it's going to go and make it available such that you can share it wide with anyone that you need to or anyone that needs to be out there. And so there's a couple hundred serverless application repository apps today, all sorts of cool things. And actually, just while we're waiting for this to launch, let me come back here. So you can see here just on like the main landing page here that there are a whole bunch for Alexa already. So we can find a whole bunch of Alexa skills. And so while Kirsch is going to walk you through here in a little bit how to build an Alexa skill yourself, you can actually come and start with some of the samples that are right in here and launch the back-end aspect of an Alexa skill. But there's all sorts of things here. So for example, let's actually search for DynamoDB, which is a database that I'm using here today. You can find all sorts of functions related to DynamoDB with all sorts of different capabilities. Let's search for APIs. So everyone loves them some APIs. So we could find all sorts of cool API-related functions and applications that are out there, S3 signed URLs, all sorts of cool stuff. So inside of the Serverless Application Repository, all sorts of things that you can look at. Going back now to the hackathon for serverless apps for social good, one of the things that you need to do is actually bundle up a serverless application and put it into the repo. And so I'm hoping by the end of today we can actually bundle up the skill that Kirsch is going to put together. But if not, you can find out everything that you need here in order to understand it. And as part of the skill that I've made available, let me go back here to Crawler. You could come in and you can actually find the Git repo where my code lives. And if you go to that Git repo, you'll see things here like my templates.yml, again, the YAML file for it that shows you kind of exactly how it is that this needs to be structured. So based on what we're doing today, you could totally go through, figure out how to do your Lambda function, figure out how to create your SAM template, figure out how to go and package it, and get yourself registered for the hackathon for social good. So Kirsch, I'm curious, have you been following along? Have you had a chance to launch this function at all, this application?
I did. I just deployed it, and everything is successful on my end.
All right,
it's pretty
cool.
nifty.
So let's go and actually go ahead and execute this function. Let me see something real quick here. How did I have this function saved? Am I in the right account? Yes. There's applications. Let's go down to, so if you want to find your function here, I go back to the Lambda main dashboard console. I see here that I have the following serverless application launched. I'm going to click on it. Gives me a bunch of information about it. I can see here that it has successfully created my application. Now, SAM, the technology that I'm using to deploy this, serverless application models, is actually built on top of CloudFormation, which is another tool that we have here at AWS. And so I'm just going to, this basically gives me all of the resources that are created. I'm going to click through to my parser. Now, here I am in the Lambda console. So it's got all sorts of stuff about my Lambda function and how it's configured. But what I want to do is put some data into DynamoDB. So I want to execute this. Now, we could go ahead and put this on like a scheduled CloudWatch event and say, hey, run nightly the ability to ingest this data. Instead, what I'm going to do here is I'm again going to set crawler days to 1. So I've gone down here and I've set this to 1, and then I clicked on save. And then I'm going to use the test event in order to trigger this via the console. And so if I click on from this drop down here for select a test event, I'm going to do configure test events. I'm going to just empty this out and just call this blank event. Because I actually don't need any of the event syntax, but I just need to pass in something. I'm going to say create. And now I'm going to say test. And fingers crossed, things will work. Cool. So it tells me that my execution has succeeded. Let's go and click on details. I could come in here and it tells me, again, just what we saw in the Cloud9 environment when I was testing it locally. So I can see the URL that I processed. I can see that it pulled in 133 events. Now, if I come back down here to the bottom, I can actually pull out the DynamoDB table that it put all this in. Because when I launched the Serverless application, it did create a new DynamoDB table for me. Let me go back to the DynamoDB console, and let's go find this table. And so if I look at this table, again, I click on it, click on items, I should see 130 something items here. It looks like there's something up with 2 of the events. I don't know what exactly, but it is now here created. So again, what did we do, right? So created my Lambda function, walked through all the steps, tested it locally. I've already prepackaged it into the application repository. It's available to everyone who is here following along, watching the Twitch. I've gone and launched it as a new application. I've executed it with a blank event. It's gone and parsed the New York City Parks website, put the data into DynamoDB. And so at this point, data is now available for us to pull out of this. And so here's where we can think about, well, how are we going to get this out? Just so happens that, again, our good friend Alexa makes it really easy to pull data out and interface and work with this. So I'm going to hand it over to Kirsch to take us through kind of the second half of this. And for those of you who've been asking questions in the chat, I am going to try to address those while he goes here and starts to talk to you about what we're going to do with Alexa today.
Cool. All right. Thanks, Chris. Well, everyone, I guess I'm going to take over from here about how we can now interface with this. So what Chris has done for us is he's taken that data that was available on a web page and he's made it totally accessible to us by putting it into a database. Now we can do a lot with this, right? We can simply create our own website, but we want to do something that's going to make us a good fit for this hackathon. So let's start by designing an Alexa skill. And I guess before really getting into design and development, we should really quickly look at what kind of constitutes an Alexa skill and how the overall architecture works, right? So on this left side, we've got our end user, and this is our Alexa device. And let me know if I have to kind of blow this up a little more in order to see it. Here, let's see. All right, cool. But yeah, what will happen is a customer or user will come to Alexa and say, Alexa, tell me a little bit about the weather. Well, that audio is then taken by Alexa, and all the device really is a microphone array plus a speaker and a network interface controller, and it'll take that sound and stream it up to the cloud. That's where the Alexa service kind of does some pretty interesting stuff with the sound bite, right? First, there's some speech recognition that's applied, some machine learning, natural language understanding, but that's all part of the magic that the Alexa service adds. It kind of does this processing layer. And from there, the Alexa service is able to create a request object. Now that object is delivered as JSON and can then be received by your service. Now you can host the service on your own server, but we're going to do it in Lambda today. But what you can do then is you can take any of the objects in that JSON, start to manipulate them, and use our SDK to start creating interactions. Once you've done a little bit of computational logic in your service, you use some directives to signify what Alexa is going to respond to the customer with. That goes back over to the Alexa service from your service, your Lambda function, and is then turned into a sound file that's streamed back over to the customer. So this happens in a loop across every single verbal interaction there is. But because we are kind of connecting with Lambda, right? With Lambda, what we can do is connect with any other AWS services, right? So in this case, it's going to be DynamoDB, but you could also perhaps push events through SNS or SQS to mobile apps. You can connect to HTTP endpoints and make APIs. So really, creativity is unlocked, right? There's just the front end that you really need to get in place, and then from there, everything interfaces through the main service handler that Alexa has. So now that we kind of got that out of the way, one of the biggest things with working with an Alexa skill, and I see this all the time, is that we have a strong body of knowledge and a very, very good understanding of what it takes to create graphical user interfaces, right? We know sort of how flows work, and if we were to see a great UI versus a poor UI, we would be able to very quickly tell the difference, right? There's this idea of consistency that's very deep. Now, voice is a little trickier because conversations are incredibly complicated. They're not as systematic as a visual depiction that graphical user interfaces work in. So what we really do to try to kind of get a grip on those design elements is we like to start with the script. So I'm actually going to borrow you now, Chris. We're going to go to storywriter.amazon.com. It's just a free screenwriting tool that we have. I'm going to log in with my personal account. And what Chris and I are going to do is we're really going to quickly mock up, if I can remember my password, we're really going to mock up what our interaction with Alexa is going to look like. So let's create a script.
Sorry, real quick. Can you go up to the top of your window and just do like a full maximize on it?
Yeah.
Give us one of those, and then like maybe a little bit of a zoom for all the folks at home. Perfect.
There we go.
Perfect.
Is that good? All right. Yeah. So we'll call this the New York City Parks Alexa scale. So in a context of a conversation, there are two parties. In this case, it's just going to be Chris. And Chris is going to start his interaction with Alexa. What would you say, Chris, if you were talking to Alexa and trying to start with New York City parks?
Yeah, I think I would say, like, Alexa, ask New York City parks, and then, about an event in Manhattan, or for events in Manhattan, maybe.
Sure. Now that's great. One of the things we like to do too is at this part is we like to script our happy path. And that happy path, what we mean by that is just the absolute simplest interaction. And a little reason we do that is because it's very, very easy to become gridlocked in all the different possibilities that people can express the same intention, right? Like you said, that you're looking for something to do in Manhattan, right? I could potentially say, Alexa, tell New York City parks I'm really bored, right? The two things essentially have the same intention, but they're very different ways of expressing it. So let's filter it down to the most basic interaction. So we'll say, Chris said, Alexa, ask New York City parks for something to do, right? And then at that point, we can have Alexa as a character come back and say, all right, welcome. Let's have some sort of a welcome message and tell Chris a little bit about what this is. Let's find an event that supports your local parks in NYC. Mm-hmm. What sounds? Oh, yeah. Well, actually, that's a good place to do it, because now here's something that we also want to do is the way we imagine a user and an Alexa working together is that the user is really driving the conversation, and Alexa is prompting the user to respond in very specific ways. So this is where the design of a very great voice interface comes from. And it's a little more subtle than just kind of taking an API and wrapping it around a UI, right? No one wants to sit there and just say a list of options, right? There has to be an elemental conversational feel to it. So Alexa says, welcome, let's find an event that supports your local parks in New York City, and perhaps provides a prompt to narrow down that choice. So Chris, if you were with your kids, maybe she says, what sounds cool to you? Nature, history, or fitness, right?
Yeah.
Chris, you could say something to the accord of, I don't know, which one of those three sounds cool?
Let's go in and add arts and crafts instead of history. My kids are a little, so the history might go over their heads. We'll do arts and crafts. Little kids like to be messy, so we'll do that. And so I would say back, arts and crafts sounds great.
Arts and crafts sounds great. And Alexa would then respond by saying something like, woohoo, arts and crafts are super cool. And what we do is, the reason we want that confirmation in there, so this is what we call an explicit confirmation. And we really want to make sure that Alexa is kind of responding with some personality, but with the confirmation that, yes, she heard you. When we're talking with people, when we're engaging in a dialogue with people, we do this very naturally, right? Like Chris, you and I were talking, we were kind of nodding. So there were these gestures that we had that provided context. Now, Alexa can't make gestures, so the way that we kind of add that implicit or explicit confirmation is we put that into the text with a little bit of personality. So we say, woohoo, arts and crafts, super cool. You can check out this, you can check out event from date, and then maybe have a description, right? Like I remember these are the fields that Chris was essentially collecting in his database. So, what we can do really quick is we can go in here, take a look at an item and see a little bit what that would look like, right? Yeah, adults will create works of art employing imaginative techniques. The name is Adults Imaginative Arts. You might not want to do it with your kids. It sounds interesting. But you would have the data presented to you, then sandwiched between kind of Alexa's personality, right? And then you can say something like, it's at, let's see, what kind of location? We don't really want to provide street address. Here, let me zoom in a little bit. So if you guys can see, this is what the data in your database is going to look like. Now, we don't really want to provide a street address because memory, when people are speaking, they don't retain a street address. Like, Chris, I'm going to tell you, 1900 First Avenue, 402 98101. Did you remember that?
Yeah, that's going to be hard.
Yeah. I mean, yeah, you do, but you're going to have to immediately go and write that down. We don't want to really kind of put that onus on our users. So we really want to just kind of give them a general sense. Now, I think location, something like Poe Park Visitor Center, is great because that essence is going to stick with your user. So you've got, it's at location in borough, because I think borough's pretty, am I spelling it right? Borough.
Yeah.
Yeah, that's it. Yeah, borough.
I guess you guys don't have boroughs out in Seattle, do you?
No, we have neighborhoods like the rest of the world, Chris. Yeah. Now, boroughs always remind me of like the Shire, like the Hobbit or something. It's out of some Tolkien novel.
Absolutely.
Yeah. But yeah, so now you've got it's at location in borough, but you still want the customer to be able to retain this information and then be able to act on it, right? There's not much you can do by just hearing something and going, okay, great. Now, what's the point of having this conversation with Alexa if I got to go back to the New York City's website, look up the same event, and then find the details there? No. But at the same time, you don't want to provide too much information because that's exhausting to listen to. It's not how conversations work. So what we'll do here is we'll take advantage of a great little feature. It's dropping a little card in your Alexa app. So if for those of you guys that own Alexas, every time you interact with the skill, it drops a little card. So if you ask for the weather, it'll drop a little card that tells you further details on the weather. We use cards all the time to kind of add further context. And this is part of multimodal design. If you really wanted to take it far, again, I said, like, after this, you go get a copy of this code or, decide to build your own skill. You can send a text to your customer like, okay, yeah, well, I've texted you all the information to that event, or I've sent you an invite, right? There's a lot you can do, but because cards are part of the native experience, we're going to say, I've sent the details, or you know what, let's say I've sent the link. I've sent a link to the event to your Alexa app. All right. You want to give this a read through with me, Chris? You be Chris, I'd be Alexa.
Okay. Alexa, ask New York City Parks for something to do.
Welcome. Let's find an event that supports your local parks in NYC. What sounds cool to you? Nature, arts and crafts, or fitness?
Arts and crafts sounds great.
Woohoo! Arts and crafts are super cool. You can check out event from date, blah, 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 description. It's at Columbus Circle in Manhattan. I've sent a link to the event in your Alexa app. There you go. And that's exactly why we kind of do a quick read through, is to make sure that there is some sort of presence to it. Now, this seems very simple, but again, dealing with the variability, adding variability to this is going to create a lot of complexity. So let's dive in to the actual development. Now, again, like Chris, I'm an aspiring chef, so I've done some pre-work here. But what we'll do is, and I've got all the notes on my table. I guess this is the cooked turkey in front of me. But what we'll do is actually go through and build this so I can share some rationale and walk everyone through what it takes. The first bit of it is the developer portal. So we have to go to developer.amazon.com. You'll have to register for a different account. It's not the same account as AWS. This is where we construct the front end for an Alexa skill. And we do this for a few reasons. Architecturally, we want to create a separation between your front end and your back end. But at the same time, this is how we can take our skill and publish it through a certification process for everyone that owns an Echo device to use. And it's good to kind of have that separated from your infrastructure, right? So I click there, I go ahead, create a skill. This is my skills dashboard. You can see I've got a bunch of skills that are in progress, but what we're doing is creating a new skill. I'm gonna zoom in a little bit on my screen, and I'm gonna hit the create skill button. Now, the skill name can be anything. This is what we would show inside the skill store. So if you guys wanna see, for those of you guys that don't have any familiarity with skills, if you go to amazon.com/skills, this is the skill store. Echoes are super cool because you can browse through the skill store, enable all sorts of skills, and then interact with them. But yeah, so the skill name is what we'll show in the skill store. So we'll just call it New York City Parks Event Finder. And we are creating a custom skill, so I have that selected right here. But there's all sorts of other skills that you can create. You can create video skills, smart home skills, right? So maybe interacting with devices, like turn on the kitchen lights. And then one of my favorites is the flash briefing. So if you ever said, Alexa, what's in the news, you could create your own little soundbite that Echo owners can enable and add that soundbite to their news briefing that they get. But for us, this is a custom skill. It's a totally involved experience. It's its own unique experience, which is why we go that route. Now we've got a few things we can do, right? We can start from one of these pre-designed templates. It's a little bit like serverless application repositories. What it'll do is scaffold the entire skill for you, but because we're building from scratch today, we're gonna hit the start from scratch button. And this is what we call the developer portal or the developer console. And the developer console's got all the tools. It's kind of like your cloud. It's like your in-browser IDE for designing a voice user interface. There are ways to do this locally, and I'll kind of throw a shout out at that towards the end and maybe do a little bit of demo about how we can develop all of this in a local environment. But I think this makes a ton of sense when you're first just kind of learning and getting exposure to Alexa skills development. Well, we're in here now. Let's take a look at what our script says, right? So there's a few components here. This Alexa is what we call the launch word, or what we call the wake word. This is what we call a launch phrase. And this right here is the invocation name. So when a customer says the invocation name, they could say, Alexa, New York City Parks, or they could say, Alexa, open New York City Parks, or start New York City Parks, right? Anytime that invocation name is said, you then enter the walled garden of your skill. It's now you're in the experience of the skill, and you as the developer or the designer have to now create the interactions for it. So let's go ahead and add that invocation name to our skill. Instead of being so wordy, we'll just call it New York City Parks. We'll save it. And then let's think about what our intents are. Now, intents are something that I really alluded to a little bit earlier. It's how do you find the intention behind what someone says? Well, with Alexa development, what someone says is called an utterance. And what we try to do is we take all those utterances and map it down to a single intent. The intent being the intention, right? So let's say that we create an intent called recommend event intent, right? Because that's our intention, is to recommend an event. Now we can see that recommend event intent was added to the intents, and we can now add sample utterances. So what might a user say to invoke this intent, right? They may say something like, let's see some of the notes that I took on this. Right, they might say, like Chris said, we can also take a look at our script, right? For something to do, right? So maybe they say something to do, right? Or I'm bored. Or what's another good one, Chris?
Oh man. Let's see.
For an event.
Yeah, I'm trying to think here. I'm bored. I'm bored's a good one. No,
let's get weird.
Let's play.
Yeah, let's play. That's a good one.
That's good for the kids.
Yeah. And you would go enter this list. Now, Now this list is how we're training Alexa's neural network to start recognizing patterns of speech. And she bases her understanding of the customer's utterance to an intent from this list. So what this list is, this isn't an enumeration at all. We don't have to type in every single combination, right? I don't have to type in also for something to do, right? Or find me something to do. I don't actually need these in there because what Alexa is doing is she's learning from this corpus that you're providing her and then making those computational logical decisions to really drive into the intent. So we really don't need to be, this specific, but it helps to have a few utterances that are unique that really get behind how a user might say something. But there's a curveball, Chris. You threw a little bit earlier, right? You were like, find me an event for a for a nature event, right? Or for an outdoorsy event, right? Someone might say something like that, or they might say for an event in Manhattan, near Manhattan, or they might even just do a amalgamation of the two, right? They might say, I want a outdoorsy event near Manhattan. So how do we make sure that we capture that? Well, that's where slots come in. So what a user says is a slot. And the way we demark it is by typing it like this. So someone might say, I want a outdoorsy event, right? So we would just say for a category event, right? They could also say, I want a historical event, or Chris, in your case, it could say I want for a kid-friendly event, for a children's event. There's lots of synonyms that can go in there. But for a category event, broadly kind of captures that. Now, someone also might just say a simple category, right? They might just say, Alexa, ask New York City parks for nature. And that's because they're just, they have some familiarity with the skill and they want to cut right through the chase, right? So we provide categories an option. And we kind of do the same thing with burrow. So let's do Bow Rough. Around Bow Rough, near Bow Rough. This is the West Coast, man. This is how we remind ourselves that Bow Roughs exist.
Yes.
Yeah. But now what we've got here, and I'm going to hit show all, is the beginning of our interaction model, right? So someone could say something to do, right? They might say for a nature event near Manhattan, for an event around Staten Island. I'm bored. Nature would work, I guess, but no one speaks like that. But what we're doing is now we provided Alexa the corpus to be able to learn how people are going to really start to invoke this intention. And the intention is to recommend an event. Well, we have to do a few more things, right? So these categories, we have to instruct Alexa what values people might say in these categories. So we go down to this slot types thing right here, and we add a custom slot for category. So we call this category type. Now this is really similar to variable types, but not the same at all. It's not like static typing that you have in Java or in any other programming languages where you say, hey, this is a float, or this is a string. What this is it's far more generic. It's kind of something to help increase the precision of Alexa's AI. So slots can be really anything, and we have tons of default slots, right? Like, if you just wanted to collect a number from the user or a duration, or 4-digit number, a date, like how many different ways are there to express a date? Chris, how would you say next Wednesday?
I would say next Wednesday.
I was gonna say besides next Wednesday, right? Yeah, I mean, well, you could pull out the actual date on a calendar.
Sure. Yeah. I mean, you could
right?
say, September, whatever. You could say like the 15th or September 15th or like I said, the next Wednesday. There's lots of different ways to verbally express that.
Exactly. You might even say the 15th of September. Well, really, all you'd have to do is specify a slot type of Amazon.date, and Alexa's AI would be able to take all of that and format it into a string that you can actually deal with programmatically. So that's so there's tons of default types like airports, animals, artists, cities. But because we're dealing with these categories that are very specific to New York City's parks, we're going to create a custom slot. And what are some of the categories? There's fitness, there's nature, right? What was the other one? Arts and crafts?
Arts and crafts, yep.
Okay, so let's start with these three. And because I'm boring and old history. So we'll start with those, and let's also add some synonyms here. So this is where we can start to deal with how people say values very differently. So let's take a look at our event intent, right? So someone might say that, they might say, let's get weird, let's play, but they also might say for a nature event, that doesn't sound right. But people would say something like for an outdoorsy event or for an event outdoors, right? They also might say, let's take a look, like, arts and crafts sounds cool, but someone could say, I love being outside, right? Like, Chris, you might just decide to say, instead of arts and sounds, I love being outside, right? So how do you deal with that relating to nature? That's where synonyms come into play. And this is a concept that we call entity resolution with skill development. So we come in here and we go ahead and we type in things like, outdoorsy. And we go ahead and add that synonym in there. And we can add things like, days of old, or the good old days, right? Being outside in the sunshine. But yeah, synonyms don't have to be one word. They can be multiple words. We're going to apply this same sort of logic to creating a borough type. So this is where people tell what borough they want their event in. So we'll say there's Manhattan, there's Bronx, there's Staten Island. What else do we got? We got Queens.
Queens and Brooklyn.
Not bad for being on the West Coast, right?
Got it, man. Yeah.
Yeah. So, some people say, the Bronx, so we can go ahead and add that as a synonym. Are there any other kind of geographical nicknames people use?
Yeah, for Manhattan, put the city.
Yeah. That's a good one. All right, cool. So we have that set up. Now, let's go ahead and actually tie this together with a back end. So we'll go in and see how we've got our front end set up here, but really we need that service that ties up to that skill that provides all the logic, right? So we have to craft Alexa's reprompts or prompts back to the customer. So if you go down on the left-hand bar, you can see how that says endpoint right there, right? So with endpoint, what we'll do is we'll select AWS Lambda ARN because we want to use serverless. And now what I will do here is I'll go to aws.amazon.com. I will first sign into the console. I'll click Lambda because we're creating a Lambda function. I'll go ahead and create a brand new Lambda function. So what we can do here is for the Lambda function, since Chris just demoed this, we'll use Serverless Application Repository. and we'll use one of these Alexa SAR templates that's already pre-built for us. So I think there's a how-to skill. There's let's use the fact skill, and we hit the deploy button. So what this does, again, as Chris had demonstrated earlier, as it creates our Lambda function for us. Now, if I go back to Lambda and if I go check out functions, I can see that I already have a ton of functions, right? We did definitely do a little bit of turkey cooking. So I've got the code already right here. And what I'll do is I will bring up the code in an IDE, so it's a little bit easier to kind of see and edit, and I'll walk everyone through it. What we've got here is we've got these things called intent handlers. So in the previous screen, right on the developer portal, if I can figure out which one the developer portal was open in. I think I blew that screen away. That's okay. We'll refresh here, pull that back up. Yep, here we are. So in this sort of, let's go back to, I think this is the wrong one. Oh no, I forgot to save. Oh, Chris. Oh no. That's okay though. I've got something else that I can show here. So one way to do it is definitely to go through. You know what's funny, Chris, is I have a hashtag called #NoSaveACurse because this isn't the only time I've done it on stream. Yeah.
Hey, that's part of live streams here.
Yeah, I know. For those of you guys that did watch that stream with Paul and I when we were building College Coach, and I got the #NoSaveACurse nickname. Please don't tweet him. He doesn't let me live that down yet. But what we're going to do here is I'm going to show you another kind of capability I have is we have this great tool called the Alexa CLI. And if you go to alexa.design/CLI, it will actually take you to our docs that tell you how to get started with this. But what the CLI allows us to do is it allows us to, from a local environment, develop all the same stuff that we would normally have to do through the cloud. So I've already got this project scaffolded in a folder called NYC Parks. So I can just do ask deploy, and what the CLI will do is it will say not found. And there you go. There's another problem with line streaming. Well, the third option is that I can just take the JSON that we've got in there. And, oh, no, here it is. Hey, I didn't blow it. All right, cool. Let's save it very quick. All right, save model. I got an error. So the slot type is missing for slot, borough, and intent. That's right. So I have to assign these types, category type. Now I can create save model. But what I was also going to show you, or show everyone here, is that what we've done and what all of this IDE does. So all of this clicking around, all it's doing is creating this JSON object. That's it. So if you become very proficient at developing an Alexa skill, you don't really even need to use this IDE. You can just go ahead and model these JSONs. But I find it way easier to do here. So that's how I was going to recover this skill. I was just simply going to be pasting a JSON model in there. So this is a complete JSON model. I can click save, right? And you can see that we've got all of our utterances in there. Now, if I go back and look at the code that we've got, how are we doing on time right now, Chris?
We're over time, but I think we're okay to keep going until one of us gets kicked out of a room here.
Okay, all right, good. So what we'll do is I will start to go fast on this part. And for those of you guys that have questions, you can always tweet me. Um, I will drop my Twitter handle into the chat. Um, if you guys do run into any sort of issues, you can always just tweet me, and I'd be happy to kind of like point you to some material. But I'm gonna start now, just cranking this high speed, low drag. But what we've got here is a usage of our SDK. So this is our Node SDK, and our Node SDK is totally built to help us form and formulate responses and reprompts from Alexa. It communicates with the Alexa service through a bunch of these directives and APIs that are really, really easy to use. So let's take a look at what we've got here. We've got this recommend event intent handler. Now, there's going to be a parity between the intents that we have and the intent handlers. So you can see in the code right here, and this is very common for Alexa syntax, is that we have, or if you're using the Node.js SDK especially, we have this can handle statement that listens into the recommend event intent. We've also got handle. So what's going on here is that anytime the recommend event intent is called through that Lambda function, well, this brick of logic is going to execute. And this brick of logic is really, really simple, right? In this case, what we've got is a launch request. So let's take a look at even a simpler use case. We've got this can handle that listens for this event called a launch request. Now, launch request is a unique intent. If you notice, there's no real launch request listed here, right? Even the built-in intents don't say launch request. What launch request is the message that Alexa will give to you if you simply say, open the Alexa skill, right? So in this case, Alexa will say exactly what Chris and I had scripted out earlier, welcome, let's find events that support your local parks. So she says, welcome, let's find an event that supports your local park in New York City. Then we have this thing called a reprompt text. And how Alexa works is if you're talking to her and she presents you with the reprompt, and the way that we can instruct her to present a customer with a reprompt is simply by adding this line number 16, she'll continue to listen for an answer. So this is how you get a conversation, right? So she's going to say, the first thing she's going to say when a customer enters the walled garden of your skill is, welcome, let's find an event that supports your local parks in New York City. You can say a specific borough like Manhattan, or just say, find me something to do. Now, because there's no interface, we want to make sure that we are kind of instructing customers very loosely what to do. So that's what she says. Then she stays awake and listens. If a customer says nothing, she presents them with a reprompt text. So let's go ahead and add that. And then again, that little card that I'd mentioned earlier, with simple card. Now, recommend event intent handler is going to be a little more complex, right? There's a few things going on. She's trying to do some entity resolution. So if you were to say in the days of old, or if you were to say if you were to say any of those synonyms that we'd kind of provided, right? She would have to basically be able to tell that. But at the same time, she has to keep a track of what everything that a user is saying. So let's take an abstract example of how a dialogue happens between Chris and I. Chris, how are you doing today?
I'm doing well. How are you?
I'm great. Where'd you get that shirt?
A store.
A store?
Yeah.
Really? Does the store have other ones?
Yes.
Okay, great. So that entire conversation that Chris had, especially that second one, it's a plain black shirt. I was like, yeah, I hope the store has other ones.
I wasn't sure where you were going with that, if you were looking for a specific answer.
No, it's good. It's good. I know I kind of caught you off guard there, but what's great about that is that the second time I didn't have to say shirts. There was this built context, right? Like I said that, are you looking for other ones? And you automatically knew that I was talking about shirts, right? Well, that dialogue also flowed in sort of this like branched model, right? Where if I were to say something like, hey, does the store also have pants? You know that I'm referencing the same store that we had initially brought up, right? Mm-hmm. So managing that dialogue can be extremely, extremely tricky if you think about all the logic that you have to build. Well, with Alexa, it's really, really easy. This is something we call dialogue management, and it's built in not only to the Alexa service, but it's also built into the SDK. So how do we enable dialogue management so that Alexa kind of keeps track of things that we're saying and then keeps tracks of the prompts that we're presenting? Well, if we go back to here, right, all we do is just simply say that category is a required slot. So this is what it'll look like in your screen if you're following along. If not, you want to repeat this later. If you've just created this category, it will look like this. I've kind of fast-tracked us, but all you do is flip it on, and now dialogue management is on. The service knows that it's on for this skill. Well, you have to tell Alexa how to prompt for that skill. So if we look here, she's prompting with what sounds cool to you, nature, arts and crafts, or fitness. If we go back to the developer portal, right, we just go ahead and put that in here. So what sounds interesting to you? I'm going to switch it to cool to you. And what would a user say in response? Like, you know, I like outdoors, or arts and crafts sounds cool, or feel like doing something outdoorsy, right? So those are, again, all the utterances that a user could say along with where the value Alexa is expecting to receive that word goes. So now that dialogue management is in, we have to now handle that kind of in our code. So in our code, we've got this handler. So within the recommend event intent, because that's where we are, right? If, again, we'll take a look back here. So these two, category and burrow, are collected through utterances in this intent. Mm-hmm. Yep. So what we do really here is we just, inside this handle block, have this logic. So we take a look inside the object that's coming back from Alexa. If dialog state equals started or dialog state equals in progress, we go ahead and add this directive, add dialog directive. And then we pass in, again, the same intent. And that's how now Alexa just sort of keeps track of the entire interaction in flight. So if you were to say category out of order, or if you were to say, wait, no, never mind, I meant to say, I don't like history, I like the outdoors, she'll go ahead and change the category ID for your selection through dialogue management. So it greatly, greatly simplifies your skill. Again, what I've done here is I've mocked up some of the data from the database that Chris had created for us. And all we really have to do is switch this out to live database calls. But before we even do that, let's go ahead and plug that Lambda function in and really try. I'm going to minimize here so I can kind of see what's going on my screen.
Yep. And just so you know, I've got that query ready for you now in the GitHub repo that we shared, when you do want to query the database.
Oh, you have that, dude. You wanna chime it to me, or do you want to chime me your ARN?
I don't have the Alexa skill up and running.
Okay. Well, let's do this, and then let's see if we're not kicked out in 15 minutes. Then let's try it. Let's try it.
Yeah.
All right. Okay. So now what we're gonna do is we're gonna kind of go to functions, and I had created this before again. So I'm gonna copy my ARN. By the way, this is a poor security practice. Never share your ARN.
Yeah. We'll clear it up later.
Yeah, exactly. We'll clean it up. But yes, we go over to endpoint and we can just drop that's not my ARN. We make sure you've copied your ARN. Make sure you're in North Virginia. And then we go back to Alexa Skills Kit and we drop that in there. And then we click Save Endpoints. Now let's go down to, let's go back to Interaction Model. All right, everything looks kind of good to us. Let's build this and then let's test this. So building takes a little bit because what we're doing right now is training Alexa's neural network all up in the cloud, how to recognize all those user intents, how to pay attention to the slots that are kind of coming in So building your model always takes time. But if you're making any changes to the backend code, that's really quick to deploy, right? Because all you have to do is push it out to your Lambda function. In any case, let's see what we've got. Again, just to do a real quick recap. What we've got are our intent handlers. Now, this code, if you guys are really curious about seeing other samples, you can also go to github.com/Alexa, where we've got a ton of tutorials, as well as like documentation around our SDK, skill samples. So you can see how events and intents and intent handlers kind of work together. But okay, it finished building and it built successfully. I got a little message. So we go over to the testing panel and we can say enabled. I'm not sure what's going on. User session timeout. Okay. Well, if your session times out, log back in. We go to the test event panel and we enable it. All right, great. So this is our simulator. This is how we can interact with an Alexa device and study what's going on. It's very, very useful for debugging. So if I were to say, Alexa, you don't have to type in Alexa. So open New York City parks. Right? We get Alexa saying, welcome, let's find an event that supports your local parks in New York City. You can say a specific borough like Manhattan, or just say, find me something to do. But what's really cool is, if you remember, you get the entire Alexa JSON input. So this is the input that's coming in here. So everything that's resting within this handler input object is right here. So you can see that I'm kind of tapping into handler input, request envelope, request type, launch request. Well, guess what? That's right here. Request.type is launch request, right? So that's really all it is. The SDK just manipulates JSON, sends it back and forth from the SDK. You can also see what Alexa is kind of getting. So she's getting a card, she's getting reprompt speech, she's also getting output speech, right? So welcome, let's find an event. Let's also try it out on her device. Alexa, open New York City parks.
Sorry, I'm not sure.
Okay, we'll try that again. Alexa, open New York City parks.
Sorry, I'm not sure.
She's being temperamental.
Is it NYC parks?
No, it's definitely New York City parks. We had it right here.
Yeah.
Maybe I'm not logged in to the right account, but that's not possible.
Say, is that one not enabled for the skill? What if you did the other test tool that you can speak through?
Like EchoSim?
Yes, yes.
Yeah. Oh yeah, this is a good one. So if you're running into problems or you don't have your device on you, you can always test in browser. Right. You can go to, now I don't have sound, but you can go to echosim.io, log in here, and then test your skill. And this is an in-browser Alexa device, and it should be completely tethered to your account.
Yeah. If you turn the console on, you should be able to speak to it, right?
Right. So if I were to say, Alexa, open New York City parks. Yep. So, well, it shows the entire interaction, have a console log, but it's also erroring out here. In any case, let's continue. We'll continue with the testing simulator, and then we'll go kind of debug this. But okay, so she says, welcome, let's find an event that supports your local parks. So you can say, right, what was it? I'd like find me something to do.
Yeah.
Yeah. So now she says, which sounds cool to you? Nature, history, or fitness. And then you could say, I'd like to. Oops. Here. Let's say Uh, something outdoorsy sounds cool. Outdoorsy, got it. So you can check out the Central Park Tour, Heart of the Park event. And let's take a little bit of a closer look at what just happened there, right? So what Alexa did was she started paying attention to these two slots. Now, let me zoom in a little bit and maximize this. So what is going on is Alexa is now paying attention to these two slots coming in, borough and category. And we've trained her to recognize them at a specific point in our interaction with her. But we've also told her that synonyms exist, right? So someone might say outdoorsy, right, as a response. Now, let's look at how the data object changed when that happened. Well, what it did was, or what was sent over to Alexa was the fact that someone had said outdoorsy, right? So that value had resolved to outdoorsy, right? So the slot value outdoorsy came in, but she was able to map it back to nature. And then we've got an ID as well that we can use for the database lookup, ID nature, right? To make that entire interaction complete. But the same thing would work, right? If you would say like, ask New York City Parks for something from the good old days. I'm wondering if that's going to work actually, because yeah, there you go. So we did it now all in one shot. Instead of having that multi-turn dialogue, I simply said, ask New York City Parks for something from the good old days. And she was like, good old days, got it. So there's the confirmation. And then she made her lookup, relayed it to you, and got it to work. Let's try one more time on the device. Let's see if she fixed herself. Alexa, ask New York City Parks for something from the good old days.
Sorry, I don't know that one.
Darn. The thing is, though, when test is enabled for this skill, when you've shifted this, like, and switched this to be on, and if you're interacting with the simulator, then you should be able to test the same exact skill from your device. Now, this could be my goof. I could have configured this device incorrectly. But in any case, you should be able to hear these interactions exactly as they are typed out and have the same sort of conversational path. So that's what we've got. We got the front end and the back end work together. We've got an experience that kind of goes together. Now we just kind of make the database lookup, right? Based on category value.
Yep. So in our chat window, I pasted you a link to the code in GitHub that you need to pull out. So it's in that GitHub repository that we've got shared. And it's commented out down below. It's a big commented block.
Cool.
So that whole thing right there.
Let's copy and paste that in.
And so basically it should be that result can be taken from there.
All right. So what I'm going to do is I'm going to comment this out. And then I'm going to uncomment this. So I can see you've got this, you got your params, right? Mm-hmm. What else do we have? Okay.
So table name, you might need to just like hard code in your the table name.
Sure.
Unless you added, did you add
there is one other thing that we're forgetting. Boom. We're forgetting to add the AWS SDK along with all our constants. Yep.
Yeah. So because we're going to have our Alexa skill running in Lambda query the DynamoDB database, we also have to include the SDK in it. Now, again, I did that before as part of my Python function, but we're building the Alexa skill using Node.js. So we need to include that SDK. Thankfully for us here with AWS Lambda, the SDK is actually currently bundled into the platform. So we don't have to do any sort of new packaging up of this. We can add those lines, and then you've got to get the name of the table that was created. So it's that, yeah, if you can highlight that.
All right, we got it. Let's just set it up here.
So I would just, I would just get rid of it. We won't have it in the environment variable. That's fine. All right, so we've got our client set up. We are referencing our table. Let's go down to this query here. So now this was set up to do with callbacks, but I guess what you could probably do is just do like a let result equals the dynamo.scan there.
Yeah, but since that would be synchronous, we would have to make it asynchronous. So we just simply add async up there, and then we can do let result equal await dynamo scan params. Yep.
Probably whack it. And then I would get rid of the callback stuff, I guess.
Oh, it is. I guess my fingers are now cramping up.
This is a long Twitch stream.
yeah. This is like a marathon. I like it. Cool. All right, so let's console log these out as well. And then what I will do is I will also go console.log.
And then the only other thing is that you're going to get a number of results. So you're going to get back like a whole stack of results from this.
So maybe we should just do like result 0.
Yeah. Yeah, well, that will spit it out there. Yeah, and then I don't know if where you then consume result, you'll probably want to do the same thing.
Yep. We're going to have to, so what we'll need is we're going to need, now this is great because this only gives you kind of one sort of, one recommendation. Obviously, we could go back to design and add a bunch of other questions like, instead of what sounds interesting to you, like, do you want to, or maybe we could continue to expand the interaction model so that she says something like, are you in the mood for something in the evening or the morning? Right? And then maybe like the kind of things that you're not going to want to filter on a GUI, right? Like maybe she even asks you, or she tells you a short story and she's like, who is your favorite character in that short story? And based on the short story, she recommends, an event, right? That's kind of what we'd want. But anyway, we'd have to go back into design to kind of really think about that and build that out. Let's just try to get this base function working. So we got console log result 0. What I'm going to do is deploy just the Lambda function. Can't find skill dot. Okay.
We're down to the wire. We've got 6 minutes left before.
I know.
We're done. We're gonna get it.
Okay, we're gonna get this done. Okay, so we deployed it. Now let's go over to Lambda. And now we're down to the wire, so Lambda is taking its time to on me. All right, we got it last modified 26 seconds ago. That's good. Let's do a test event. And this is a really useful debugging feature. If we go back to here, what we can do is we can simply copy this entire, so I'm going to zoom out here so you guys can see the whole thing, but you take this entire input, copy and paste it into the test event as we'd kind of seen before when Chris went through it, and we call this, good old days, or we'll call it one shot, since it was a one shot. And we'll just hit the test button. That runs the thing as Alexa would expect it, and it kind of gives us a printout of the logs. We're not seeing any console logs here. Uh-oh.
Scroll up to the top. Oh yeah, you can find it here. Yep.
So this is CloudWatch, and it takes this is our latest event. So if I were to expand these, what I should be saying is all of our log statements, but they're not there. No. All right, let's see. Really quick, what are we missing here?
We're not seeing any errors.
We're not seeing any errors.
Is it because we went async and so it's returning a result before finishing that?
I don't know, but we've got await, right? So like async, that should be okay.
Yeah.
Is there anyone on the is there anyone on the stream that can spot it? Nope.
Strange.
Yeah, this is strange. All right, well,
Cool.
let's go back to your callback expression. So here.
But you're not even seeing the result thing, right? Like plus results. That should show up.
Yeah, we're not really seeing any of it. Which
You definitely
is
saved this when you deployed it, right? You saved the file.
Yeah.
Oh, let's see. If you look, you should be able to see the code. If you go back to the Lambda console, and you go and just back to the Lambda function, back and scroll down. Let's make sure the code actually is in here. So if you scroll all the way down, you should see. No, it's not
It
there
didn't
yet.
make it.
Aha!
All right.
Plot thickens.
The plot does take in. Looks like I've got some local environment issues I need to fix. Okay, we're gonna be super hacky about it because this is a hack for good.
Yes.
Theme
Copy
stream.
and paste it in.
We're gonna copy and paste it in. We're gonna hit the test button, and we're still not gonna see anything. Oh no.
Really?
Yeah, really. There are no logs. I'm wondering if here, let's step through. Let's go old school, Chris. Let's step through a code. So like if it's in progress, right?
Well,
but it's not.
Do we have everything pasted in that it would get to that part of the code?
Yeah.
Jack Smash says refresh the browser.
Refresh the browser.
We'll try it. We're desperate.
We'll try it. Jack Smash, if you're right, oh boy, you're gonna get some Twitter love today.
Yeah.
Nope.
No dice. Womp womp.
I know. And
all right,
we're coming on time, so
we are. So we're gonna have to call it a break here, folks. But we're gonna round up after this and try to figure it out. We are going to try to get this skill published into the app repo here real soon. So you can come back and try to look for the Alexa New York City Parks event skill. Once we get this up and working, we'll get it in there and have it like in reference to the crawler. It's been a long session here, right? We've been going for 2 hours. Did you figure it out?
No, but what I was going to say, it's been a long session. I mean, we've done, but think about it. 2 hours, we've created a full backend with a resilient, scalable database that crawls from a live data source. We created an entire interface that essentially works, and it deals with everything from having a conversation about finding something to do to being able to just one-shot it, right? We've done, I think, a lot in 2 hours if we only had 15 minutes more. Yeah,
exactly. So bring it all back to the beginning, right? Right now, there are 2 hackathons going on you can find on devpost.com. There's the Amazon Alexa Skills Challenge Tech for Good with an emphasis on the environment and local communities. Today's kind of attempt at getting this together was kind of in that vein of thinking about local parks and going to them and what you could do there. The other one is the AWS Serverless Apps for Social Good. And so in this, basically, the idea is you create an application, bundle it up, running on Lambda, bundle up the SAM template, put it in the serverless app repo. And this one is a little bit more focused on, for example, we've teamed up with some number of profits that have dedicated themselves to ending human trafficking. Now, you don't necessarily have to have a function or an application that is focused exactly on that. But again, same kind of idea, right? Hackathon for community for the greater good. Summarizing again here, we've done so much. So we created this crawler. You can find it in the serverless application repository already today under the, if you search for just the word crawler, it'll pop right up. We built our Alexa skill to put it over it and mocked it at least with some test data. We're so close. I know we're probably missing something really, really small.
Yeah.
But want to thank you all for joining us here today, for those of you who stuck around for the whole time. Again, my name's Chris Munns. I'm currently lead developer advocate for serverless at AWS based in New York City. Akursh?
I'm Akursh Srivastava, a senior solutions architect for the Alexa team in Seattle. And thank you guys again so much for joining.
Yep, thanks for joining. Have a great weekend, and we hope to see you soon here on Twitch.
Yep, and we'll post on Twitter once we have the code up, so definitely follow or tweet us. See you guys.
Take care.